Hello, everyone. Today we're diving into the world of hydronic heating. If you've ever walked into a home that just felt perfectly warm, no drafts, no noise, just cozy, you might have been experiencing hydronics. We're going to break down exactly what it is, why it's becoming the gold standard for comfort, and the physics that make it work.
So, what is it? Put simply, hydronic heating is using water to move heat from where it's made to where it's needed. Think of the water as a conveyor belt. It picks up heat at a source, like a boiler, carries it through pipes, and releases it into a room. Ideally, that same water stays in the system forever, just looping around and around. Now, why do we use water? Here's the cool part. Water is incredible at holding heat. In fact, a specific volume of water can hold over 3,400 times more heat than the same volume of air. That means we can move a massive amount of energy through a tiny pipe, whereas an air system needs huge, bulky ductwork to do the same job. Let's talk benefits, starting with comfort. This one surprised me. Comfort isn't actually about adding heat to your body. It's about controlling how your body loses heat. We lose most of our heat, about 60%, through radiation to cold surfaces around us. Hydronic systems warm those surfaces up, which stops that heat loss and makes us feel naturally cozy. Then there's the money aspect, energy savings. Get this, studies have shown that homes with forced air systems can have 26% higher air leakage than hydronic homes. Why? Because blowing air around changes room pressure and forces heat out through cracks. Hydronics doesn't do that. It's sealed, silent, and doesn't mess with air pressure. Another energy waster is stratification. You know how hot air rises? In forced air systems, you might have 90-degree air stuck at the ceiling where no one lives, while your feet are freezing. Radiant hydronic floors keep the heat down where the people are. If you aren't overheating the ceiling, you aren't wasting fuel. The design flexibility is wild, too. One boiler can heat your bedroom radiators, warm your bathroom floor tiles, heat your domestic water, and, wait for it, even melt the snow on your driveway. Plus, because we aren't blowing air around, we aren't blowing dust, pollen, or pet dander everywhere. For allergy sufferers, that is a huge deal. To really understand this, we need a quick physics refresher. Heat always moves from hot to cold, and it travels in three ways. Conduction, which is heat moving through solids. Convection, which is heat moving through fluids like air or water. And radiation, which is heat traveling through space like light. This is the secret sauce of hydronics. Thermal radiation. Think of sitting by a campfire on a cold night. The air is freezing, but your face feels hot. That's radiant heat. It travels through the air without heating it and warms you directly. Hydronic radiators and heated floors work exactly the same way. Okay, let's look at the hardware. Every hydronic system is made of 4 basic subsystems. You have the heat source, usually a boiler. You have the distribution system, the piping. You have heat emitters, the things in the room that release the heat. And finally, the control system, the brains that turn everything on and off. Inside that loop, we have some critical components. We have a circulator, basically a pump that moves the water. We have an expansion tank, because water expands when it gets hot and needs somewhere to go. And we have a pressure relief valve, which is a critical safety device that pops open if the pressure gets too high. You'll often hear the term closed loop. This just means the system is sealed off from the atmosphere. The water inside is reused over and over. This is crucial because it prevents oxygen from getting in and resting out your iron components. If you have to keep adding water, you're adding oxygen, and that's bad news for your boiler. Finally, the goal of all this design is something called thermal equilibrium. It sounds fancy, but it just means the point where the heat we're putting into the water matches the heat the house is losing. When a system hits this balance, the water temperature stabilizes, and your home stays at that perfect, steady temperature. So, to wrap up, Hydronic heating uses the incredible heat-holding power of water to deliver energy efficiently. It maximizes comfort by using radiant heat, keeps our air clean, and offers massive design flexibility. It's a smart, sophisticated way to heat a building. Thanks for listening.